In this video, I'll be finding the arc length of one arch of the cycloid defined by the equation xt equals r times t minus sine t and yt equals r times 1 minus cosine t, where t is between 0 and 2 pi. If you like, you can pause the video and try having a go at the problem on your own before having a look at the solution. Okay, let's have a look at the solution. So firstly, we can graph this cycloid using the equation. So for example, when t equals 0, so when t equals 0, we have x equals 0 and y equals 0, and it goes all the way up to t equals 2 pi. And at t equals 2 pi, we have x equals 2 pi r and y equals 0. So we get a shape like this for the cycloid. And we just have to find the total arc length of one arch of it. So we can apply the arc length formula from integral calculus. So the arc length formula is the length of the arc is equal to the integral from 0 to 2 pi of, so it's a square root of derivative of x of t squared plus derivative of y of t squared. So we can calculate what these inside terms are. So x of t from the equation was r times t minus sine t, and y of t is r times 1 minus cosine of t. So if we find the derivative of x of t, we get r times 1 minus cosine t, and the derivative of y of t is r times sine t. So if we calculate the sum of the squares of the derivatives, we get r squared times 1 minus cos t squared plus sine t squared, and expanding out the cosine 1 minus cos t squared, we get this plus sine t squared. However, we also know that cos squared t plus sine squared t is equal to 1. So this allows us to simplify it to 2 minus 2 cos t times r squared. And now we can look at the double angle formula here. So cos of t can be written as cos of 2 times t over 2, and using the double angle formula, we get 1 minus 2 sine squared t over 2. This means we can write 1 minus cos t as 2 sine squared t over 2, and timesing both sides by 2, we get, so this 2 minus 2 cos t over here, we can actually write it as 4 times sine squared of t over 2. So this means that the sum of the squares of derivatives of x and y is, so we have r squared here, and then timesing it by 4 sine squared of t over 2. This means the square root, so the square root term over here is equal to the square root of 4r squared sine squared t over 2. And this can be quite easily, we can quite easily take the square root of this. So we get 2r here, and might have to be a bit careful here because we need the absolute value of sine of t over 2. And also we can take the square root because r is at least 0. But we can recall, since t ranges from 0 to 2 pi, it means t over 2 ranges from 0 to pi. So that means sine of t over 2 is at least 0. So actually we can remove the absolute value signs here, since sine of t over 2 is non-negative. So we get 2r sine of t over 2 for 0 less than equal to t less than equal to 2 pi. And so this allows us to do a final calculation. So the integral becomes the integral of 2r sine of t over 2 dt from 0 to 2 pi. And taking the integral, we have 2r times negative cos t over 2 from 2 pi to 0. And now we can calculate, we can substitute 2 pi and 0 in for t, and eventually we will get 8 times r as our answer. So this is the length of the arc length of the cycloid. Okay, so that completes the proof of this question of finding the arc length of the cycloid. So hope you enjoyed this video. Thanks for watching, and I'll see you next time.